run the game. It's going to start the game, and by pressing the arrows we can see the snake move, and once it collides with the food, the score increases as well as the snake increases in size. So now we're going to show when it collides with itself. So let me just grow it inside. Yep, and then now it's going to collide with the wall. It's also going to be game over. And now we're going to show autopilot. When we press Y, it's going to basically play the game itself. And there is no crashes and it's running smoothly. So now we're going to go to discuss the code. Okay, so first of all, we're going to start with the main class, where it's going to instantiate the game class and run it. The game also creates a snake and a normal food class, which extends the food class. Has details on the color, size, nutrient value for the score growth, each food consumed. The snake makes use of the collision manager class, which detects all kinds of collision. The snake makes use of the Pathfinder class for autopilot running the BFS. So how the solid principles are applied. So first, if you want to add a new feature to the game, how easy would it be to add? It would be relatively easy since we did apply the OOP and the solid concept into the program. And examples of new features includes adding a new type of food, which creates a new type of food class with any color, size, nutrients value we want, and just extends the food class and makes use of it. Adding a new type of obstacle, we just need to add one function to the collision manager class and make a call to it. For the solid principles applied, the single responsibility principle, some examples was the snake handling body movement. The food handles the food details like position and nutrient value. Again, this determines how much the score should go up each food consumption. The game handle input detection, and the clock ticking for the game. The open-close principle, we use OOP inheritance principle to ensure that our design is very open to extension and closed for modification, just like how we implemented for the food class. The Liskov substitution principle is able to replace a parent object with a child object, which is like creating and making use of the food object. And for the dependency inversion, it's basically like creating a new type of snake and pass it into the game. I guess this sums up the presentation. Thank you for watching.